Hello, everyone. My name is Semih Sonkor, and I'm a PhD candidate at New York University, and I'm a graduate research assistant at NYU Abu Dhabi, and I work with Professor Borja Garcia de Soto. And today, I will take you to another aspect of construction digitalization, which is cybersecurity. So, cybersecurity in construction, what do we think about it? Is it relevant, or should we really research it? Is it something needed? My answer is yes, it is, because in 2022 we saw that as a part of a report, we saw that construction was the most targeted sector by ransomware attacks in 2022. And ransomware attacks are where hackers are encrypting your data and they're asking for money to decrypt it. So we are seeing this increasing interest from hackers against our sector. And it is because of obvious reasons, because there are huge volumes of cash flow in the projects. And now we are also starting to implement robotic equipment. And because of that, the cybersecurity concerns are starting to lead into safety concerns, because these systems can interact with the humans around, the machinery around, and it can cause safety problems. So we conducted a survey back in 2022, and we saw that many people we asked, they were actually concerned about cybersecurity in the sector, which was surprising. And we saw that many people think that there are more resources needed dedicated to cybersecurity in the construction sector. So this is the problem. But before going into the solution, what we are proposing, I would like to talk about a competition that we have been organizing since 2022, because I will use this as the case study for my proposal. So this competition is the first academic-driven cybersecurity competition in the construction context. And it has been organized since 2022 as a part of a bigger event called CISO, and it is the largest student-led cybersecurity event in the world. So far, there were, I think, more than 3,000 participants. And as a part of our competition, we are asking the students to compromise the collected data and functionality of a given robotic system in construction. So the first year it was an autonomous monitoring robot, construction progress monitoring robot. The second year it was an autonomous excavator. And this year it is an autonomous soil compactor. And in the competition first round, we are asking them, how would you compromise this system? What would be the most vulnerable components? How would you improve it? What would be your motivation? So we are making them think about possible ways to compromise the system and possible ways to improve it. And in the final round, we are inviting the finalists to our campus, and we are asking them to demonstrate what they can do, how they can really hack these robotic systems with a smaller example of a robot. So I will show you a small video to show you how it looks like. So there are these arenas, there are small autonomous robots. These robots are mostly educational robots. And now you will see there are students around these arenas trying to hack into the robots and trying to make it hit different objects or trying to steal some data. So this was from last year. So, okay, what is our solution and how we are using the data from this competition as a case study? So the solution has two aspects. The first aspect is crowdsourcing. What is it? It is gathering ideas by leveraging the contributions of a large group of people. So let's say we have a specific problem in our company or in our sector, and we would like to get the expertise of large groups of people from different sectors, different organizations, or just from all around the world. We can use this kind of approach by asking people. And in our case study, the crowdsourcing part is Hack My Robot, the competition. And we are collecting ideas from students related to cybersecurity issues and mitigation strategies related to the given system. And the second aspect of the solution is called topic modeling. And it is a statistical method to identify the most common words or word groups in a body of text and cluster them under various topics. So as an example, let's say we have 100,000 tweets from Twitter or from X, And we want to identify what were the mostly emphasized topics, mostly emphasized aspects within these 100,000 tweets. So we can use topic modeling to identify them. Again, in our case study, we use the collected data from the students, and we identify the most emphasized cybersecurity issues and mitigation methods. So this is the a little bit more technical part, but I will just go through it one by one without going into too much details. So the first step is collecting data, because if we would like to perform some data analysis, we need data. And in our case study, the data is the first data source is the answers to open-ended questions that I just mentioned. How would you compromise the system? What would you do to improve it, etc. And second and third data sources are the poster presentations, the audio from the poster presentations, because at the end of the final round, the teams are talking about what they did, what they intended to do, what kind of tools they used, what would they do to improve the system. So we have the audio from the presentations, and we have the text from their posters. So now we have three data sources. Next step is in every data analysis and in every data analysis, the second step is data cleaning and pre-processing before the actual analysis. So we did the same thing. We cleaned the data and we stored it in a database. In our case, it was just Excel, because we are just doing this whole process once a year, so we don't need a complicated database. And then the next step is segmenting the text into smaller pieces, text segmentation. Why is it needed? Because we received answers from 27 teams, and maybe each team provided us maybe 100 sentences in the overall answers. So if we provide these 100 sentences as one document to topic modeling will think that, okay, there is one topic in this 100 sentences. So we will miss many, many aspects that is mentioned in this body of text. So we need to divide it into smaller, meaningful pieces, so that we can see, okay, in these 100 sentences, there were these different topics. So this is very necessary step of the overall process. And this is how it works. The first step is identifying the sentences. So we say, okay, this is sentence 1, sentence 2, sentence 3 using a Python library. The second step is creating embeddings using a machine learning transformer-based library called SBERT. And embeddings are just vectors, some mathematical representations of sentences. And the critical part is they capture the semantic content, so they capture the meaning of sentences. And the last step is identifying the borders of the segments, because as I said, we want to identify segments, smaller segments, that are semantically coherent, so meaningfully similar. For that, we are using something, the method called cosine similarity. So if you think about vectors, this is vector x, vector y. This is a very simple like 2D dimension. And we have some angle between these two vectors. So if we get the cosine of this angle, we get the similarity, which varies from -1 to 1. If it is getting closer to 1, it means that they are very similar to each other. Actually, they are on top of each other. Theta is 0, so cosine 0 is 1. So they are almost the same as each other. And if they get different than each other, then the cosine theta is getting lower. So just to show how it works, I will give you a small example. Let's say we have 5 sentences and we want to identify different segments semantically coherent. So we check sentence 1 and 2. We calculate the similarity. If it is more than the threshold value that we assign, let's say 0.5, okay, they are similar to each other. They are in the same segment. Sentence 2 and 3, similarity is bigger than 0.5, the sum value. Okay, they are also similar to each other. They are in the same segment. We check sentence 3 and 4. If we see that similarity is smaller than the threshold value, let's say again 0.5, okay, so these are about different topics. So we need to separate them. So they are from different segments. And then sentence 4 and 5, again, the similarity is higher than the threshold value. So they are also similar to each other. They are in the same segment. So this way, we identified segment 1 and segment 2. Okay, sentence segmentation, oh sorry, the semantic segmentation is done. So now finally we can use it for topic modeling to identify the topics in the overall text. For this purpose, we used again, it's a combination of different algorithms. It's a Python package called BERT topic. This, I won't go into the details of how it works, but the advantage of BERT topic is it uses transformer-based algorithms, which is very powerful in identifying semantic content. And another advantage is it is, as you can see, it is modular, so you can change different algorithms for different purposes. So, but what is the outcome of topic modeling? What do we see? We see this, different keywords for different topics identified by BERT topic. Topic 0 is about robots, access, computer, external communication. So if we think about each topic based on these keywords, we can understand what they are talking about. But wouldn't it be better to have just some sentences explaining them? I think yes. So for that purpose, we are using GPT, which is really good at summarizing, labeling data. So we are providing, okay, these are the representative documents, which are different segments that we identified, the most relevant segments to each topic. And we have these keywords, which I just showed. Can you summarize this topic with a label and a short paragraph? So based on what we have, how can you summarize it? So these are the labels that we get. For example, the topic 0 was labeled as security vulnerabilities in robot operating systems, and it goes like this. But again, we don't understand what they are talking about. Okay, they are very high-level titles, but we want to learn a little bit more. So we check the summaries. We can see topic 7 is network security, intrusion detection and prevention systems. And here we see some details of the topic, which can give us more insights. And before going into the final step, we also did some parallel analysis using VOS Viewer, which you might have known. It's mostly used for bibliometric analysis, and it gives us keyword coherence maps. So using the same data set, we created this keyword coherence map to understand what are different clusters in this data set. They are about denial of service attacks, password cracking. I won't go into all of them one by one. But the point is that using these topics, different topics from topic modeling and different clusters from keyword coherence map, they are actually aligned with each other. We can categorize them using each other, so they are complementing each other. And finally, the most important step after everything is human interpretation. So we have all the topics and summaries, but what do we do about it? How do we take an action? So we need to have the human in the loop. So let's say we have topic 6. It's about enhancing security in firmware and software updates. And we saw that, okay, the Raspberry Pi Foundation recommends using this tool for fetching and applying firmware updates securely from the official repository. So we can take the action of using this tool, if we are not using so far, for updates of Raspberry Pi. So this can be one of the actions that we take as a result. So what are the limitations of this study? Oops. So the data that we used from Hack My Robot is very limited because we just started in 2022, but as the years pass, it will be more, we will have more data to analyze and get more results. The second one is the hyperparameters for different components can be fine-tuned a little bit more rigorously. Like we did grid search to fine-tune, but it could be more rigorous. And the final thing is we didn't compare BERT topic, which is the topic modeling part, with other topic modeling methods such as LDA, which is very common. Conclusions and future work. Okay, we know that cybersecurity knowledge exists, but we also know that it's not efficiently used in the sector. So this approach takes this unstructured cybersecurity knowledge, which humans possess, and it provides useful insights for decision makers in the sector. So by engaging the people who knows about cybersecurity, we can guide the decision-making process in the sector. And as a future work, we will investigate different ways of crowdsourcing knowledge. And for that, we are starting to collaborate with a construction company, and we will provide them a platform to collect ideas and some insights from cybersecurity experts about a specific about a specific technology that they are using in their construction site. So it will give them some insights about what they can do about cybersecurity. References, and thank you for listening.